In this video, I'm going to look at another example finding the standard equation of ellipse, and then we'll be able to identify the center, the vertices, and the foci and the eccentricity. And to start off, this one's going to be a little bit different. If we notice again here, we have our standard form, but this equation is not going to be in standard form. We have to write it in standard form first. So if we have 9x squared plus 4y squared minus 54x plus 40y plus 37 is equal to 0. So in order to find the graph and to find the center, the vertices, and the foci, we need to first put this in standard form. So the first step in doing that is we want to group our x terms together. So we would have 9x squared minus 54x, and then we would have our plus 4y squared plus 40y, and the 37 that's by itself, we just want to simply move that to the other side. So since it's a positive, we're going to subtract it, and then it means over here we would end up with a negative 37. All right, so now, just like we did when we were dealing with the parabola, we went into completing the square so that we would have a perfect square trinomial. And here we have 9x squared minus 54x. We need to do the same thing in order to complete the square. Now, if you recall, what do we need to do in order to complete the square? Well, first of all, the coefficient here of the x squared must be a 1. So it's not a 1, so in order to get rid of this 9, we want to take these two terms and we want to factor out the 9. So if we factor out a 9, we're left with x squared, because 9 divided by 9 is 1. And if we factor a 9 out of the negative 54, then we would end up with 54 divided by 9, which would be a negative 6x. And then I'm going to leave a space because we're going to add on to make this a perfect square. And then once again, we have the 4y squared plus 40y, so we want to do the same thing. We want to change our coefficient here so that it's a 1y squared. So we'll factor out the 4, and we'd be left with y squared, and again, take the 4 out of the 40, and we're left with 10y. And we want to leave a little bit of space to add on our number to make it a perfect square, and we still have the negative 37. So now when it comes to completing the square, we have the negative 6, and remember, if we think of this as ax squared plus bx plus c, or just in this case ax squared plus bx, if we want to complete the square, we want to take half of our b value, which is the coefficient of the x, and then we want to square that number. So for us, that means we're going to take half of a negative 6. So we have a negative 6, and we take half of it, and we want to square it. So half of a negative 6 would be a negative 3, and a negative 3 squared would be equal to a positive 9. So that means we're going to add 9 here to make that a perfect square. Now we have to be careful. Where did we put the 9? We put the 9 on the inside of the parentheses. So that means at some point that 9 is going to be multiplied by the 9 out front. So even though it looks like we added 9, we really added 9 multiplied by 9. So we really added 81 to the equation. So we added 81 to the left side of the equation. That means we have to add 81 to the right side of the equation. Then if we go on to the y squared plus 10y, here we have the 10, so that means we need to take the 10, divide that by 2, and square it. So half of 10 is 5. 5 squared is 25, so that means we need to add on a 25. But once again, we have a 4 out front, so we really didn't add 25. We added 4 times 25, which is 100. So because we added 100 to the left, we also have to add 100 to the right side of the equation. So now we can come back. We have our 9, and we have x squared minus 6x plus 9, which now that is a perfect square, and that's going to factor to x. Well, how do we figure out what this factors to? Well, if you go over here and look, when we had a negative 6 divided by 2, that would be a negative 3. So that means this is going to factor to a negative 3. So x minus 3 squared is going to give you x squared minus 6x plus 9. So what that means, if we were to take x minus 3 times x minus 3 and multiply this out, we're going to get the trinomial. And then we want to do the same thing over here with our y's. We still have the 4 out front that we factored. And if we factor this to a perfect square, we take half of the 10, which is 5, so that's a positive 5. So we get y plus 5 squared. Then we have the negative 37 plus 81 plus 100, which is going to be equal to 144. So now, are we getting closer to this standard form? Well, if we look up here, the only thing that's different with the standard form is that we do not have anything multiplied in front of the x minus h squared or y minus k squared, and also the equation is equal to 1. So if we look at our equation at this point is equal to 144. So if we want to make it equal to 1, we could certainly just divide by 144. So that means we have to divide everything on the left by 144 as well. So now if we look at this, we would have 9 over 144. Well, if we take 9 over 144, we need to simplify that fraction, and you could put that into the calculator if you want to. 9 over 144 is going to simplify to 1 over 16. 9 into 9 goes once, and 9 goes into 144 16 times. So therefore, this would simplify to x minus 3 squared over 16. And then we could do the same thing over here with the 4 over 144 and simplify that fraction to lowest terms. 4 into 4 would be 1, and 4 into 144 would actually be 36. So therefore we end up with y plus 5 over 36. And of course 144 divided by 144 is equal to 1. And here we have our standard form. And if we look at this closely, we have the 36 is here. So what does that tell us? That tells us that the a squared is 36, the b squared is 16, 36 is larger, and we know that that's going to give us a major axis is going to be vertical. All right, so now from here, if we want to then calculate the center, we could do so. So we know the center is going to be the h and k. So here we have our h and our k value. So h in this case is going to be a positive 3. K is going to be a negative 5. And then I guess we could go ahead and calculate a squared. We said is going to be equal to the 36. So that means a is equal to 6. B squared is equal to 16. So therefore b is equal to positive 4. And if we want to calculate the c value, c squared is equal to our a squared of 36 minus b squared of 16. So c squared is equal to 20. So c equals the square root of 20. And we could think of 20 as 4 times 5. So the square root of 4 is 2, and you're left with the square root of 5. Or we could simplify that and say, well, that's going to be approximately 4.8. So now that we have the center and our A, B, and C values, let's go ahead and see if we can actually start to sketch out the graph of our ellipse. All right, so we know that the center is at 3, -5, so we could plot the center first. So we're going to go over 1, 2, 3, and down 1, 2, 3, 4, 5 to a -5. So there we have the center, and I'll go ahead and label this as 3, -5. And now we know that we're going to look at the A value, because the A value is going to give us the distance to the vertices. And we know this is going to be vertical, we said earlier. So that means we're going to be going up. So that means we need to add 6 to the y coordinate. So if we're going to calculate the vertices by adding to the y, -5 plus 6, well, that's going to give us a +1. So that means we would be at 3 and 1. So that gives us 1 point. And then that means we would go down 6. So if we take a -5 and we subtract 6, that would move us down to a -11. So that would be at 3, -11. So there we have our vertices. And if we want to calculate then the using the b value, we could help find the minor axis. We know b here is equal to 4, so that means we would go to the left 4. So that means we're looking at the x value. So 3 minus 4 would give us a -1, so that would put us here. And then we would have to add 4, so that would put us over here at 7. So that would be right about here. And we could look at the ellipse would go something like this. And after we calculate that, we could look at the foci, and that means we're looking at the c value, and we know that's approximately, we can use the decimal here, 4.8. So we're going to go up, and I guess you may see them use the exact answer, but as far as graphing here, we'll look at the 4.8, so not quite 5. So if we're here at 3, -5, then that means we need to go up approximately almost 5. So that would put us, if this is at -5, then that means we would be almost here to the x-axis. And then we would go down here to almost at 8. Or sorry, well, let's see, we have a -5, and to the -5 we need to take away 5, so that would actually be almost 9 rather. So that would put us at 9.8, so right before we get to 10. So there we have our points. And if we want to use the exact value, we could label that as x is 3, and what you may see actually listed as a multiple choice, or if you're looking in your book, you may see them actually just write, say there's your x coordinate, and they say, well, here we have our y coordinate -5, and we need to add on and subtract 2 square root of 5. So 2 square root of 5 is what we need to add and subtract to the -5 to get our 2 points. Okay, so that's probably how you're going to see them write this, as to keep an exact answer. So they'll just write it as your y value here, -5. Let's see, this is our y value, and then we want to add to it the positive 2 square root of 5, and then we want to subtract 2 square root of 5 to get the 2 points. And then, of course, if we're looking at calculating the eccentricity, we said that was going to be E is equal to C over A. So in this case, our C value is 2 square root of 5 over 6. And if we were to put this into the calculator, this would be approximately 0.75. And that's closer to 1, so that you notice here we do have a little bit more of an elongated shape as opposed to more of a circle. So here you have an example of how we need to, first, given the equation, we have to take the given equation and put that in standard form, and one of the techniques here that you're probably going to use if that's the case is to complete the square. So just remember that when you complete the square, the coefficient of your x squared and y squared here must be 1. If not, you're going to factor like we did here. We took out a 9 and we took out a 4. And just remember, when you complete the square, whatever we put on the inside has to be multiplied by the factored value out front, and then we have to do the same thing to the other side of the equation so that everything keeps the equation balanced. And then once we do that and we get this into standard form, you can easily calculate the center, the vertices, and the foci.